Alright chemists, it's happening. Metals. As you can see, the vast majority of all elements are metal, and we can use metals, we can either use them individually, like uncombined, so just the native element, or we can use them as alloys, which we'll get a bit more, well, we'll do it now. Metals, generally they have a relatively, that should say relatively before that, high melting point or boiling point. They tend to be malleable and ductile, they're good conductors, and they're solid at room temp with the exception of mercury. You should know this is generally a revision. An alloy is a solid homogeneous mixture of the metal, the base metal, and one other element, or more. It can be either metal or non-metal, doesn't matter. For example, steel is a mixture with carbon. Bronze is copper and tin and so forth. Alright, so the earliest found were the native metals or the elemental metals, and they were used for jewelry, tools, weapons. Not so much the very early ones because that's gold. They were easier to extract, and if they were easier to extract, they were earlier to be discovered. So gold, we believe, is the first one that was found. It's 10,000. This is before present, so that just means 10,000 years ago, the Egyptians were mining gold. Now, and they're using their slaves. And I think at one point in the south of Egypt they had about 100 gold mines. Alright, so time can be split up into ages. For example, if you go 9,000 to 5,000 years before now, before present, we have the Copper Age, and then overlapping with that we have the Bronze Age, which is an alloy of copper plus tin. We go 6,000 to 3,000 years before present, and then we have the Iron Age, which was 3,500 to 2,000 years before present, so before right now. Let's look a bit closer at copper. So let's look a bit closer at copper right now. So copper was first extracted from a mineral called malachite. We see the Cu. So this is the formula of copper, how it exists in malachite. You can see here it's not an elemental. You can have elemental copper mined from the ground, but they believe that this one here was found through copper just melting out of it, either in campfires, or which happens, or in kilns, clay kilns, which they've had for thousands of years. So basically it's CuCO3, so copper carbonate, joined with or mixed with copper hydroxide, copper 2 hydroxide. So it was extracted by smelting. So you mix it with coal or carbon to smelt it, to heat it up. And this has two chemical reactions, or two steps that matter. So you have the malachite here, it heats up and it breaks down to, so using the bond energy which we talked about previously. So it heats up and you get this copper oxide. Okay, you also get gas, carbon dioxide, and water. That should be a G. It's water, it'd be water vapor at that heat. But you get this black solid of copper 2 oxide. So then, as that continues to heat, it mixes with the carbon, it reacts with the carbon, and you get copper on its own as a liquid, and carbon dioxide again. So this one would be a pot with coal mixed in, and they blow air into it to increase the heat, and it's got a little hole down the bottom, and the liquid would just drain out and solidify underneath. Now, finally, let's finish off with a rough overview of the history of the discovery of metals. So first in the discovery of metals generally related to technology, and we don't just mean that you find your first YouTube clip of Slayer and you go from a sad person to a happy metalhead. What we're actually talking about is the different technologies we can use for either getting the metals out of the ground or extracting it from the ore and so forth. So most metals were discovered in the last 200 years. Up until about 1200 AD, only 7 were discovered. Like, that's it. There was only 7 metals. But after about 1200 AD, we can see that it all started to happen rather quickly. So first off, before 750 BCE, so before Common Era, we've got gold, silver, copper, tin, lead and mercury, and then nothing for ages. Until about 1200, when we start to really get some proper smelting technology, we can really heat stuff up in a way we couldn't do back here. And that's when we get zinc and bismuth. Then in the 1700s, we started to get things like cobalt, nickel, manganese, tungsten's a W, uranium, titanium, and chromium, chromium. And in the 1800s, we started to get even a bit fancier. For example, sodium and potassium, which is not extracted via heat. Calcium, magnesium, also not extracted by heat. Aluminium, indium, gallium and radium. And then in the last 120 years, we've discovered, again, a heap more with now, at this point, by the way, we're no longer we're not discovering metals at all anymore. Now we're making new metals by getting heavy elements or heavy atoms and then just bashing them together so hard that they collapse in on themselves and join and become one. So first we've got europium, rhenium, francium, neptunium, plutonium, curium, named after Marie Curie, and Einsteinium, named after Albert Einstein. There's some others are named after people, which is pretty cool. So you've got Seaborgium, Americium, which is named after an Italian scientist, and a few others. So yeah, alright. Rad, stay awesome, remember, metal, see you later.